The M1 Abrams is a world-famous battle tank, widely used by the United States Army and other countries. Built for modern armored warfare, it's among the heaviest tanks in service. It has an average weight of 68 metric tons, which is about the same as 63 compact cars. And even with all that weight, it can reach a top speed of 67 km per hour on the road and 40 km per hour off-road. There are several notable features of this tank, such as the fact that the turret has sloped sides to deflect projectiles upward. It offers nuclear, biological, and chemical attack protection, the so-called nuclear, biological, and chemical protection systems, which create positive pressure inside the tank, preventing contaminants from entering, and the fact that the cannon remains fixed and locked on the target, even if the vehicle is moving over inclines or extremely rough terrain. In addition, another remarkable feature is its modularity. Most of its components were designed to be easily repaired on the battlefield. This includes the tracks, which are the most fragile component and the most likely to fail on the tank, as they can break when hit by artillery or even due to adverse terrain conditions. The engine, the automatic transmission, armor panels, among others, are all designed to be easily repaired and replaced, even while on the battlefield. But perhaps one of the most remarkable features of the M1 Abrams is its engine, which is different from most of the engines used in tanks in service, like the Leopard 2 from Germany, the Challenger 2 from the United Kingdom, and the T-90 from Russia, which all use diesel engines, while the M1 Abrams is equipped with a gas turbine engine, the Honeyway Advanced Gas Turbine 1500. This type of engine is more commonly found in aircraft than in ground vehicles. This engine is identical to those used in airplanes. In concept and in operating principle, both work on the same fundamental principles of air compression, combustion, and converting energy into movement. But it doesn't stop there. The engine of this tank can operate on a variety of fuels, such as diesel, aviation gasoline, JP, 8 kerosene, and alcohol. Just think about that. This multi-fuel capability was designed for strategic, logistical, and operational reasons, giving the engine a unique versatility that exists in only a few other tanks. This multi-fuel capability was designed with combat scenarios in mind, especially during prolonged operations and in unfamiliar terrain, where the availability of a specific type of fuel may be limited or completely non-existent. Thus, a multi-fuel engine allows the M1 Abrams to run on virtually any available fuel, including even alcohol, ensuring that the tank can continue its mission regardless of the local supply conditions. But it usually uses diesel because this fuel has some specific properties, such as not igniting easily, even when exposed to a flame. Due to the operating principle of gas turbine engines, it becomes easier to make them compatible with a variety of fuels than purely diesel engines. Another advantage of this type of engine is its weight, only 1.1 tons, making it lighter than its diesel rivals. Another advantage is the power and the power-to-weight ratio, with the engine delivering 1,500 horsepower for a relatively light and compact engine. This gives the M1 Abrams exceptional acceleration and mobility on the battlefield, but it comes with a major drawback, which is high fuel consumption, using approximately 1.7 to 2.5 times more fuel than other tanks such as the Leopard 2 Challenger 2 Leclerc and the T-90E. The M1 Abrams holds 1,900 liters of fuel, compared to 60 liters in a regular car. All this fuel is necessary because the M1 Abrams consumes fuel at a rate of about 3.8 liters per kilometer on varied terrain. A popular car uses about 12 km/h in the city and up to 15 km/h on the highway. With a full tank, the M1 Abrams can travel about 150 to 250 kilometers on varied terrain and just over 400 kilometers on highways. A popular car can go over 600 kilometers in the city and just over 800 kilometers on the highway with a full tank. Both the advanced gas turbine 1500 engine of the M1 Abrams and the jet engines of aircraft are gas turbine engines. They work by compressing air, mixing it with fuel, and burning that mixture in a combustion chamber. The high-energy gases resulting from this combustion pass through a turbine, which spins and generates the mechanical energy needed for propulsion. Or, in the case of the M1, for the traction of the armored vehicle. A gas turbine engine operates on a simple principle. It's identical to the jet engines used in airplanes today, but let's understand it using a jet engine as an example. The process starts at the front, where a large fan sucks in atmospheric air and usually sends about 20% of this air into the engine, while the other 80% passes outside the engine, which will generate the propulsion for the airplane. Effectively, it's this 20% of air that goes into the engine. It goes through a series of several compressor stages in sequence, which will compress the air, or in other words, make this air very compact. This air then continues on its path and enters the combustion chamber, where it will be mixed with fuel, and the ignition of this mixture will occur. Once ignited, the high-speed air resulting from this combustion is directed to spin the turbine. And it's the spinning of the turbine that produces mechanical work, making the fan shaft at the front spin. In the gas turbine engine, the principle and the process are exactly the same, with the difference being that there isn't that big fan at the front, and the design can be slightly different from engine to engine. In the M1 Abrams, the principle is the same. Air enters through the front and is then compressed by the various compressor stages. With the difference of Kaiki, all the air enters the inside of the engine, then passes through the high-pressure compressors and is ignited in the combustion chamber, making the turbine spin. This engine has two separate shafts, the secondary one, which is connected to a gearbox, and is driven by the high-pressure compressors, supplying electricity, hydraulic power, among others, to the tank systems and the primary shaft, which is connected. The main turbine is what turns the gear wheel, which makes the tank move, passing first through a reduction gearbox. And as gas turbine engines, they generate a very hot jet of air at the rear, which makes them extremely visible to heat-seeking missiles. In the M1 air, first goes through a heat exchanger, mixing with cold air from the compressors. This makes its signature much more discreet. It is expelled from the back of the tank but remains very hot. Tanks have tracks, also called caterpillars, instead of the tires that cars have, and they have several advantages. The first is the better distribution and transfer of the vehicle's weight to the ground. This prevents the enormous weight of the tank from damaging the pavement wherever it goes, something that could happen if the weight wasn't distributed so well. The other advantage is that tracks significantly increase the off-road capability of the tank, actually, of any vehicle that has tracks. It can cross any terrain and overcome large obstacles without getting stuck. However, a small disadvantage can be in the way tanks turn, because to turn, tanks speed up one of the tracks more than the other. This always causes minor pavement damage. This could get worse if it does a 360 in place. But this shows that despite their heavy weight, tanks are actually quite maneuverable. And did you notice how stable the cannon was during the spin? The stability of tank cannons is impressive and well executed. Plus, there's an interesting story about them. In 1986, the German armed forces wanted to showcase the quality of the Leopard 2 tank's suspension and cannon stabilization system. To do this, they placed a glass of drink on the tip of the 120mm cannon and drove the tank over rough terrain. And indeed, The tank's systems accomplished their mission and kept the glass perfectly stable without spilling a single drop. And it's exactly this same cannon that, starting in 1980, began to be used on the M1 Abrams. Rheinmetall, the German manufacturer, licensed RH 120 technology for United States production, where it was adapted and renamed the M256. It is still made today mainly for the war in Ukraine. Having proven to be an extremely well-made gun, it is a smoothbore cannon, which means that the inside of the barrel is smooth and doesn't have rifling like most gun barrels usually do. It has grooves so that the bullet spins and increases its accuracy. In this cannon, no rifling increases projectile speed and long-range accuracy. The M1 Abrams is a main battle tank, or main battle tank developed in the United States and widely used by the United States Army and the Marines, also exported to several global allies. The tank was named after General Craig Abrams, a notable commander during the Vietnam War and a former Chief of Staff of the United States Army. Since its 1980s introduction, the M1 Abrams stood out for its combination of mobility, armor, and firepower, becoming one of the most advanced and respected tanks in the world, especially because it has a multi-fuel jet engine inside,